The title of the talk as it stands today evolved because in reality the work started in 2009 for the 150th anniversary of the book, The Origin of Species. And at the time I was invited to give a talk at the Lebanese American University on Darwin and his theory in Beirut, and I worked with one of my former students at LAU and I was there. And you have the title up there, a very interesting title, Syrian Street Dogs, Milk Teeth, American Missionaries and the Levantine Media. And in fact, that talk evolved to become what is today's talk. In the fall, it would have been totally different because I was going to focus mostly on AUB. But then I met Sally, a former student of mine who has just finished her master's degree at St. Andrews in political science, and Hannah, who has also just finished his master's at St. Andrews in international business, but he has a background in history. And they were both interested in Darwin's theory. So I approached them and we decided to take this talk in a different direction, and this time to basically talk about the influence of Darwin not only at the level of AUB, but also at the level of the nation. So I'm going to take you through the journey today from the golden age of biology in the mid-1800s all the way to the 60s, or maybe early 70s, 60s. We're going to start with a brief introduction about the golden age of biology. Being a biologist, I'm going to introduce my concept of evolution and see if it matches how you define evolution. Then we will talk about AUB and the founding fathers and how evolution played an important role in the history of this institution. We will then move to the prodigal sons of AUB, the graduates who had stands on the theory of evolution. Then we will take two figures, Anton Saadi and Sata al-Husari, and we will discuss how the theory of evolution affected or influenced their work. So if you have any questions, please try to keep it till the very end. I will be very happy, together with Sally and Hannah, to entertain any question you have. If I'm going too fast, also please let me know, because I tend to do that. I tend to speed up a bit. Okay. So I'm going to start with a little quiz, because I'm a teacher. And I'm going to start with a quotation by a very famous author whose initials are CD. And he wrote a very famous book that was published in 1859. Any ideas? Charles Darwin. Charles Dickens. Which book? Dickens? Who says Darwin? Darwin. Who says Dickens? Okay, well, you win. Charles Dickens. A Tale of Two Cities. The book was published in pamphlets, but then it was grouped together as one book in 1859. And it begins as follows. This is the very famous quotation from A Tale of Two Cities. It was the best of times, it was the worst of times. It was the age of wisdom, it was the age of foolishness. It was the epoch of belief, it was the epoch of incredulity. It was the season of light, it was the season of darkness. It was the spring of hope, it was the winter of despair. We had everything before us, we had nothing before us. We were all going direct to heaven. We were all going direct the other way. So this is how A Tale of Two Cities starts. It was published just the same year as Darwin's influential book, The Origin of Species. Now, why am I starting with this? Because the 1850s were the best of times and the worst of times for biology. Three people were very important figures in the 1800s, and they contributed a lot to modern biology. The first guy is the French Claude Bernard, who was the person to study diabetes. In fact, he did a lot of work on the role of pancreas in controlling the concentration of sugar in the blood of humans. And he was among the first people to introduce modern physiology and apply it to modern medicine, which was until then mostly restricted to surgeries, which were done in a very tough way because anesthesia was not common at the time. The second one was Louis Pasteur, the famous microbiologist, and his most important contribution is introducing modern microbiology and its implications in public health, the industry, and agriculture, in addition to medicine. Because he was among the first people to talk about what we know today as pasteurization, which is basically boiling things or heating things in order to kill the microbes in them. So modern sterilization. And then finally, Charles Darwin, who actually talked about evolution, but given that very little was known about genetics at the time, he couldn't really put applications to evolution in modern science because very little was known about genetics. And so there were no immediate technological applications at the time to his theory, and that lent the way for it to be used in the social context. And that's why if you look at the history of the theory, it wasn't until probably the mid-19th century, mid-20th century, when it became a big part or a bulky part of biology. Before that, it was mostly applied in the social realm, mostly as social Darwinism. So I'm going to now start in Beirut in the 1800s, talk a bit about Darwin's theory here at the university, and then take it from there. So before we do that, it's very important that we agree on a definition, because otherwise we would be talking about different things, naming them the same way, or maybe talk about the same thing but name them differently. So I'm going to start by asking how you perceive evolution. What do you think evolution is? How do you define it? Any volunteer?
It is a change which brings new species into life, and also, to me, I think it is a natural creation rather than just the influences and created special creation.
Okay.
Le besoin crée l'organe. Le besoin crée l'organe. The need.
The need. Adaptation. Okay, so the need for something makes something happen. Okay. Any other ideas?
Crocodile, his feet and.
Okay, so organisms acquire traits because they need them.
For me, it is changes in the body or the human being, if we're talking about it, in order to be able to survive in a different situation and in a different way of life.
Okay. Well, thank you so much. All of these definitions were extremely informative. And as you can see, there's one thing in common between all of the definitions: change. And to me, evolution is simply change through time. It's the change in any attribute of a population of individuals through time. So biologically, evolution is change through time. It's the change in any characteristic of the population through time. And therefore, it's a fact because we see this happening. So if we look at ourselves, we are all one species. We are all humans. We are very different from each other, yet very similar. And we are different from our parents, and from our children, and from our grandchildren and grandparents. And so in a matter of a few generations, we are seeing change in action. This is evolution, or at least this is one aspect of evolution which everybody accepts. And this is an empirical fact because we see it happening. But most of the time when we're thinking of Darwin and evolution, this is not the aspect of evolution we're thinking of. Most of the time, we're thinking about how we humans evolved. And this is just one example. The diagram that I used before is just one example of how we perceive evolution, right? So, how come evolution in this sense is a fact, but whenever we talk about evolution, we call it a theory? I mean, have you ever heard anybody refer to evolution as a fact? It's always the theory of evolution. But we just said, by definition, evolution is change through time, and that's a fact. It's actually an empirical fact. We see it. So,
yes, the fact that we are not seeing this change currently, it is in history. We will not witness the change in the future. It's a theory for us.
Okay. Any other feedback? Yes, there's somebody in the back. Is there another microphone? Sorry, the teacher in me just has to do this. Yes, please.
I think it's because there is a debate between creation and evolution. So for creationists, probably evolution is still here.
Okay, so we go back to the example that our friend Dr. Ghanem gave in the beginning. Natural creation versus theist creation. Okay, I'm gonna use this. This comes with a cable, so I will try to deal with it. Okay, so, no, it's fine. We will keep, oh, you, please.
Pardon me. How can we be certain that evolution is empirically true, since we cannot prove neither a negative or a positive control?
Okay, so the question is, we cannot prove or disprove evolution, so thus it's a theory because we can't really prove or disprove it. Well, most of the time when you think of evolution, you think of how humans changed. And you know, they show you all these fossils that have been found at different times, like Lucy, that was found in East Africa, this hobbit man that was found recently on islands in the East Asia. So you do find a lot of examples of this in the literature, and this is what comes to mind when you think of evolution. Well, that's not exactly evolution. It's something under evolution called descent with modification, which means that we are descendants of ancestors who were not exactly like us, but we had acquired changes that made us a bit different than what they are. And most of the time, when you talk to a biologist who is into evolution, the evidence for descent with modification is fossils and the fossil record. And most of the criticisms you get of that is that the fossil record is incomplete, which means you do get evidence for change, but there are some changes that you have to assume because you don't have fossils that indicate that they actually happened. And remember that when we are talking about evolution in this context, now we are talking about a timeline which is way beyond our perception. We're talking about a different time scale. But even that, I would argue, is a fact, except it's not an empirical fact. We don't see it because we don't live to see it. It happens on a time frame bigger than ours, and so it's more of an inferred fact. We look at the fossils and we conclude it must have happened. But when we say theory of evolution, we're talking about neither of these. We're not talking about change through time. We're not talking about descent with modification. We are actually talking about something that Darwin came up with, together with Alfred Russel Wallace independently in 1858, and that is natural selection. So the theory is how evolution happens, not what evolution is. So evolution is change through time. It is descent with modification. How that happens, which is the theory of evolution by natural selection, that's the theory part. And in science, that's the best you can get. You cannot prove it 100% true, but you cannot disprove it either, just like the gentleman in the back said. And that's the definition of a theory. It's true beyond reasonable doubt. You can't really say it's 100% true, but at the same time, it doesn't mean it's not true, because it has not been disproved. And in science, you can only disprove. You don't usually prove something. You try to disprove it. So here's an example of evolution from our everyday life. I don't think it's the season for the flu now. We're past it. But most of the time when you get some infection, microbial infection, specifically bacterial infection, you go to the doctor and you ask for prescription, and they would give you an antibiotic. And they would tell you, you have to finish the whole prescription even if you are feeling better. This is because the bacteria in your body, just like us, are quite diverse. They don't look alike. They are different. Some of them, they can handle the drug you're taking. They are not going to be killed by it. And some of them, they could be killed by it. Now, when the drug companies make these drugs that you take, they design them in such a way that they would kill most of the bacteria in your body and leave behind only a few that your immune system can deal with. So let's say you start taking the antibiotic and the red bacteria you see up there are susceptible to the drug, but the blue ones are resistant. What will happen in your body is that the drug will kill the susceptible bacteria and leave the resistant behind. You start feeling better, you stop the drug, your immune system is overwhelmed now because the bacteria are multiplying, but now you get a new population of bacteria which is entirely resistant. And you take the antibiotic one more time, but it doesn't work again because it's mostly bacteria that are resistant to the drug. This is evolution in action. This is basically change through time as well. But again, that's not the theory. The theory is basically natural selection, which is an explanation of evolution that, as I said, Darwin and Wallace came up with independently in 1858. Darwin working or having worked mostly in the Galapagos Islands and in South America, Wallace having mostly worked in East Asia. And they came up with the same explanation for the observations that they have seen, what we know today as the theory of evolution. But most of the time when we're talking about this theory, it's Darwin's theory. Wallace is kind of left out. And this is because only 1 year later, Darwin published a very famous book called On the Origin of Species by Natural Selection. This book was so anticipated because the theory came up in 1858 that all the copies sold out in one day. And in fact, 6 editions were published during the lifetime of Darwin. That's a very short period relatively. Taban, Darwin, he kept editing the book again and again and again, mostly trying to explain how we pass traits to our kids because he had no idea about genetics, and mostly trying to explain how the first living things came to existence, which sometimes he said that they were created by a creator, sometimes he said that they were breathed to existence without referring to a creator or creators, but that was mostly the change that he actually did. So the book was extremely controversial. You probably know about this because most people, just like when I asked in this room, many of you linked it to the history of people, so the ancestry of humans. So the book was extremely controversial because many people assumed a misconception, which I'm going to talk about in a bit, which is the fact that Darwin said that we are apes. Well, we are animals biologically. We are related to apes. We are not exactly apes. We are, according to Darwin and the evolutionary biologists, we are descended of ape-like ancestors. But this doesn't mean that we and the monkeys are exactly the same, or we and the chimps are exactly the same. So here's a summary of how evolution happens in a modern sense. And I promise this is the last bit of biology we're going to discuss because we want to get to the fun part. But we have to do this general introduction in the beginning. So in modern evolution, it starts at the level of genes. Genes code for what we look like and what we are like. So most of the things that we show, our phenotype, is determined by our genes. And these genes mutate, they change. And this change most of the time is random and most of the time is bad. But there are good mutations. And these good mutations, they give some individuals advantage over other individuals in terms of fitness. And in biology, fitness is a function of the number of kids you leave behind. It has nothing to do with strength. Now, then the populations are going to evolve because we are born with a fixed set of genes. We're not going to change all of a sudden. But the population as a whole will change by having more individuals who are more fit and less individuals who are less fit. So, in general, if the environment changes, we have 3 options. We leave, go somewhere else where the environment is suitable for us, or we stay and we can do nothing about it, so we become extinct, or actually we adapt. And that is basically evolution. And I will end this section with 3 myths about evolution. The first one is the survival of the fittest being the survival of the strongest. And this features a lot in the literature of Nazis and fascists and other movements that used social Darwinism for different purposes. The fittest in biology is the individual that leaves behind more kids. And so it has nothing to do with strength. The second misconception, and I think somebody brought it up here, is that we get things because we need them or we want them. This doesn't happen. In fact, mutations happen randomly. They give some individuals advantages that just happen to occur at the right time in the right place. And they just happen to be selected for or favored. And therefore, in evolution, there is no design. It's kind of getting some design, getting something that looks so neat and designed, but in reality, it's a result of many arbitrary changes. And so it is kind of a design without a designer. Okay? So let's get now to AUB. But before we do that, I have to emphasize time and again that Darwin was unaware of the work that was being done on genetics during his lifetime. And so while this father, Gregor Mendel, was working in modern-day Czech Republic on genetics, he was not aware of his work. And therefore, he could not really explain how things move from generation to generation. And this is why biology was hindered by the absence of genetics. And this is why social sciences used at the time the theory of evolution in a more pronounced way than biology. So let's go to Beirut and the Levant. In 2009, I collected as many books published about Darwin in Arabic or translated into Arabic. And here's a picture of some of them. But I'm not going to talk about them now. I might refer to some of them during the talk. We're going to start at home here at AUB with the founding fathers or the patriarchs. This is a picture of the founding fathers of the Syrian Protestant College, the ancestor of AUB in a way. And I'm going to select a few of those that have dealt with evolution one way or another and discuss them. And I will start with the gentleman standing up in the middle top, and this is George Edward Post. George Edward Post is buried at the Anglo-American Cemetery, which is not very far from here. And his gravestone reads, missionary, teacher, surgeon. In fact, that leaves out botany, which is a very important contribution of George Edward Post. In fact, he wrote the first flora of Lebanon, Syria, and Palestine at the time in Arabic, Nabat Surya wa Palestine wal Qitr al-Masri wa Bawadiha. Well, he basically focused on Sinai, so it's not the entirety of Egypt. This book was then translated to English by Post himself and followed by another volume, and still considered to be a reference on the flora of the region. In fact, the collection that was used to write this book is housed in the biology department at AUB. All the plants that are mentioned in the book are actually preserved at a herbarium named after George Post at the biology department. Now, Post was highly influenced by a very famous Calvinist called Pierre-Edmond Boissier from Geneva. And he used to call him our master, and he used to refer to 19th century Geneva where he lived as Mecca. And Post donated his books to Jaffet Library. And George Post used Pierre-Edmond Boissier Flora of the Orient. It's called Flora Orientalis in Latin. And in the introduction, Post underlines just one sentence, and I've written it here. I do not accept to any extent the Darwinian hypothesis. So he doesn't even call it a theory. And that is right at the time. Do you know the difference between a hypothesis and the theory?
Yeah.
Okay. Any volunteers? Microphone?
A hypothesis is a temporary explanation of something.
Mm-hmm.
A theory is a model that can be tested to see if it is true or wrong.
Okay. So basically, a hypothesis, as Dr. Ghanem said, is kind of an explanation which is yet to be tested in order to decide whether it is accepted or rejected. Once it is tested repeatedly and it is tested enough by many different people, it can become a theory. So at his time, Darwin's theory of evolution was not yet repeatedly tested. And so it was a hypothesis. So you can imagine George Edward Post at AUB. Actually, there's a very funny story about him. He died, well, it's not funny that he died. He died in 1909 of a bacterial infection when he was teaching the medical students that bacteria did not exist. He actually didn't believe in bacteria because he believed that you could only believe in things that you see. And so we didn't see bacteria, they didn't exist. But unfortunately, in 1909, he died of a bacterial infection. And strange enough, it must have been in his teeth. That's where it began. And his training was in dentistry. So very interesting character. Another very, very interesting character is William Van Dyke. Now, when it comes to Darwin at AUB, Van Dyke is probably the most important one. Now, this is not the Van Dyke after whom Van Dyke Hall is named. This is the son. The father, Cornelius Van Dyke, who is most famous for his translation of the Bible into Arabic, is the one who the building is named after. William Van Dyke was the son. He was a biologist and a member of a biology department for a long period of time. He was a zoologist by training, and this is what Daniel Bliss, the founding father, says about him in a letter. He says, Howard, who is his son, gives such accounts that I hope you may yet make up a strong team by getting him in the traces. So this is Dodge talking to Bliss about Bliss's son, Howard Bliss, the second president of AUB. He's telling him that he's such a great person, you should involve him in the university. And then he says, William Van Dyke may also form a great accession to your force. This is the same guy who went against the missionaries by corresponding with Darwin himself. In fact, I tried to track back the correspondence, and the first letter I could find was one coming from Darwin to him, which I find very strange because you would expect him as a less known scientist to write to Darwin, but I couldn't locate any correspondence before this one, January 25, 1882. It's close to the time when Darwin passed away. And Darwin writes to him asking him about his opinion on milk teeth. And thus the title of my first presentation. And he asked him whether he thought that male incisors were actually longer than female incisors, being an animal biologist. The second and more interesting correspondence comes in February 27, 1882, when Van Dyke wrote a paper about Syrian street dogs and how they evolved. And he sent a copy to Darwin because it was customary at the time, if you want to publish anything in the Journal of the Linnaean Society, to have a fellow of the Linnaean Society introduce you. And so he sent him the paper, wishing that he would get an introduction from him so that the paper gets published in the Journal of the Linnaean Society. But unfortunately, Darwin was sick, and the reply came from his son, saying that his dad was sick, and he's going to look into this when he feels better. And Darwin did look into this later, because we have a reply from Darwin himself just before he died. 16 days before he died, he wrote to William Van Dyke at AUB, telling him that he read the paper, he wrote a brief introduction, and forwarded it to the appropriate journal, which is the Proceedings of Zoological Society of London. And the paper was published actually in that journal with a brief prefatory note by Darwin himself. So this shows that at the intellectual level, there was correspondence between AUB and Darwin himself. Now, towards the end of his life, he gave a series of lectures about his view on evolution. And they are compiled in a book, of which there is a copy at the archives of Jafet Library. And the book is called An Evolutionist's View of Religion. And in this book, he basically refutes an anthropomorphic God, and he argues that he is more in favor of the fact that evolution could be the divinity's way of creating the world. So he kind of got into a compromise between religion and evolution. So he accepted evolution in the context of religion, claiming that it is God's way of creating the world. So God is not as human as we make him seem, and it seems that evolution is his way or his method that he used to create the world. So you can refer to this publication. It is at the archives of Jafet Library. It's a very small booklet. Now, most of the time when we think of Darwin at AUB, we think of the Lewis Affair. I'm not sure how many of you have heard of the Lewis Affair. Anybody here? Yes, okay. So one person. So the Lewis Affair is named after the famous professor of chemistry and geology, Edwin Rufus Lewis. And Edwin Rufus Lewis was a missionary as well. He was typical of the members of the medical school at AUB, a medical doctor. He was a soldier, he was a minister, he was a researcher, he was a philosopher, professor, writer. He got his MD from Harvard with distinction, and he was ordained a Presbyterian minister before he joined the faculty of the medical school. Yes?
Can you just slow down?
Yes, okay. I'm very sorry, I tend to do this, so I will try to slow down. So this is basically the life of Edwin Rufus Lewis, who was on the faculty of the medical school in the 1800s at AUB. Now, just for those of you who don't know it, I just showed you a book written by Post in Arabic about plants of the region. This is because the teaching language at AUB was Arabic. So when they started teaching in 1866 onward, the language of teaching was Arabic. All the professors, Americans and non-Americans, they spoke Arabic fluently, and they wrote textbooks or translated textbooks to Arabic in order to teach the local people, because that was part of the mission of the university. And all of these people, including Lewis, were fluent in Arabic. So Post, Van Dyke, Lewis, Wartenberg, Bliss, Dodge, they all knew Arabic. And they could converse fluently in Arabic. In fact, there was a professor called Dennis, and he didn't like his name in Arabic because it means najis. And so he changed it to Anis because he didn't want the local people not to interact well with him. So they were really versed in Arabic. They could do jokes and translate, so they were really great people. So what happened? In 1882, on graduation day, graduation is this weekend, on July 19, Lewis was asked to give the graduation speech. It was typical that they would ask one of the faculty to speak on graduation. And he gave a talk called Knowledge, Science, and Wisdom in Arabic. You could find it in the archives. In this talk, he considered 4 people, including Sir Charles Lyell, the geologist, Charles Darwin, the biologist, Louis Pasteur and Robert Koch, both also biologists. He considered them to be ideal men of science. That made the missionaries just furious, because he mentioned Darwin as an example of an ideal man of science. And so this led to different reactions from the faculty. The faculty became divided. Some people sided with him. Some people sided against him. The missionaries weren't happy. Some of the intelligentsia in the region were not happy. And this led to a big dilemma that ended with firing Edwin Rufus Lewis. And with that, the resigning of many of the faculty members who could speak Arabic and changing the language of instruction to English, because they couldn't really at that time find enough faculty who could speak the language fluently to be able to teach in it. They actually had to change the language of instruction. So this is 1882. So the consequences of this Lewis affair, it caused a student revolution. In fact, many students, including prominent ones, like Georgi Zaidan, for example, left the university. And they just wouldn't continue their studies here. Some of them, they actually finished their studies with Van Dyke, the father, and then went to Istanbul to do their license exams for medical school. Some of them, they went to Egypt to continue their studies, and some of them just quit, and they became famous writers. The faculty lost very important figures, like the 2 Van Dykes and other faculty members, and also, most importantly, the language of instruction changed, and the medical department itself, its future was threatened. In fact, in the archives of St. Joseph, as Hannah found out, there are many references to this event and how they saw the end of the medical school at this university, because they thought this will be like the detrimental thing. It's going to end the medical school. But the university survived, so that's why we're here. So now we will move to the next generation. We talked about the founding fathers. The next step will be to talk about their students. The list is extensive. We can talk till tomorrow just about this generation. In fact, when I got interested in this, it was the students I was interested in, because very little was known about their contribution. But unfortunately, I was sweet, because some historian from Egypt and the US, she published a book called Reading Darwin in Arabic, where she focuses on this generation. And so I'm not going to discuss Faris Nimr, Ya'ub Sarrouf, and many of the others who really contributed to this field. I will just restrict my discussion only briefly to two people, and those are Farah Antoun and Shibli Shmayil. Okay? So we will take these two examples, then we will move to Saadeh and Hossein. Maybe I should ask if you have any questions before we move to the next part, because question in the back? Yes, microphone. Okay. Thank you.
I just wanted to ask, at the beginning you said evolution is change.
Right.
But shouldn't it be rather change to the better? Because if it's only change, then 600 years before Darwin, Ibn Khaldun mentioned change on the social level.
Exactly. Actually, it's not only change at the social level, which was mentioned before Darwin. Darwin was not a pioneer in the fact that he pointed out evolution. In fact, evolution predates Darwin maybe to the dates of the ancient Greeks. Because change is something they've been talking about throughout. Now, how that change happens is what Darwin talked about. And it is change to the better in a way, because if it is change to the worse, you would be wiped out. And so the ultimate aim of evolution is to actually make things better. And better is not best. Better in the sense that you are better adapted to the environment. But the best may not be there. So in a way, it is better, not best. Yes, sir?
But it's still a theory, isn't it?
That's a bit tricky, because it all depends on how you define a theory. It is still a theory. It will always be a theory, because in science, a theory is the golden standard. A theory will not become a law.
How about Newton?
Well, that's a law. A law is different from a theory, because a law refers to the generalizations of facts. So if you generalize facts, you get a law. If you generalize explanations, you get a theory. So Darwin's theory is a theory because it explains facts, whereas Newton's law is a fact. It's just stating a fact. So it's a law. In a way, yes, because you tend to, both of them could be refuted. You could get a paradigm shift. For example, you know how Einsteinian physics changed Newtonian physics. That's in a way also change in a law. The laws were modified. So E is equal to mc squared, which is Einsteinian statement. It actually changed classical physics. So laws do change and theories do change, and both changes are called paradigm shifts because they cause major changes in the field, because now you're refuting something that has been accepted as true for a long period of time, whether true entirely like a law or true beyond reasonable doubt like a theory. So a theory is as true as you can get when you are dealing with explanations, because if you want to prove a theory correct, you have to prove it in every instant, and that's something that's not doable. That's why we say beyond reasonable doubt. If you know statistics, we often accept hypotheses at a certain confidence level, like 95% confidence or 99% confidence, and that's when we fail to reject them. Because in science, you have an explanation that you try to reject. You don't try to prove it correct, because you can't prove an explanation. Okay? Yes. I don't know what this
is. Cloning and evolution.
Cloning is, so the question is, how does cloning have to do with evolution, or how does it relate to evolution? Where does it fit in the picture? Cloning is simply making copies of us as we are. So cloning is simply making an exact copy of me, like you would have an identical twin for me. That's a technique in biotechnology that is based on modern genetics. And it doesn't have to do with evolution, because it's not something happening naturally, and it's not going to lead to any change in the population. It's just making copies or duplicates of me. Now, how ethical that is or where it's going to lead, that's something else. I'll take one more question.
Can we continue?
It's diverting the topic altogether.
Okay. So we'll continue now. So let's discuss Shibli Shmayil and Farah Antoun. I'm going to start with Shibli Ishmael, who was really famous for being a materialist. And a lot could be inferred about him, but we're just going to stick to the basics that we could infer directly from his work. So he believed in a long and gradualist view towards change. And he believed that this change is going to lead to a socialist utopia. Remember, he was living during the days of the Ottoman Empire. And at the time, he believed that the society as a unit evolves just like populations evolve. And so he was trying to apply biological principles in social contexts. But he wanted to figure out what the ultimate product of this evolution is going to be. Yes, he agreed it's a slow process. Yes, he agreed that it comes from the society, which he viewed like an organism. And yes, he did agree that it's going to evolve to the better. But he believed that societies were fragile. And therefore, he believed that it is much better that things will evolve in such a way that you would keep the Ottoman Empire, but now you will have a new version of the Ottoman Empire, where in this version, it's an inclusive empire based on secular citizenship. So he believed that this is the direction in which the society is going to be evolving. It's cooperation that is going to lead to the evolution of a secular Ottoman Empire. So this is one view that was influenced by social Darwinism at the time. This is Shibli Ishmael. Now, Shibli Ishmael was also known probably for his translation of some prominent works of evolutionary biologists of his time, in addition to his contributions to a very important magazine, or let's call it a journal, that we believe we couldn't lay a hand on. It's called Al-Mustaqbal. He issued a few, or he contributed to a few issues, and then it was stopped or banned, and we may have to visit Egypt to check these issues. Now, the second, he was a graduate of AUB, by the way. He graduated from the university with a medical degree, and this is why I'm calling him the prodigal son, because he was the student of those missionaries who were against evolution. Farah Antoun is probably known for his kind of debate with Muhammad Abdu, the Grand Mufti of Egypt and at Azhar. And he believed also in a long and gradualist view of evolution. He also applied it to society. He also looked at the society as an organism. So that's kind of scientization of society. So applying scientific principles to social elements. And he was quite different from Ishmael in the sense that he believed that change had to be led by a technocratic expert class. So there should be a group of more informed people in the society, including what he referred to as the scientific elites. And he believed that those are the people who should lead the change in society, and not the clergy, and not the people themselves. So he believed that there should be the more responsible, more educated elite who are going to lead the scientific change and cause the society to evolve. Okay? Now, we're not going to dwell on these, as I said, because basically I'm going to spend more time on Saadi and Husari. So let's now move to Antoun Saadi. And you probably know Antoun Saadi, the founder of the Syrian الحزب السوري القومي, the Syrian Nationalist Party. So 1904, 1949. We're going to divide our discussion of Saadi and Husari into 4 parts, as you see in your outline. We're going to first start with his view of evolution. And Saadi accepted science. So he basically accepted evolution as a scientific fact. It's something that's scientifically accepted, so he accepted it. And he tried to apply it in the context of the evolution of the society. So first of all, and this is very important, he associated social change with environmental change. So if you see today social groups that are different, those must have been the result of environmental changes that must have happened earlier in history. So different social groups, they kind of evolved because of different environmental situations. He believed that some groups stagnate, so they didn't change much, and that he attributed to stable environments. So when the environment is stable, basically the groups would not change. And he believed in two types of evolution, and this is very much in line, by the way, with modern evolutionary theory. He believed in two types of evolution. One, gradualism. This is when evolution happens so slowly and so gradually. So what we are today is the result of gradual changes that happened over time, and they took place so slowly. We are only looking at the final outcome. But he also believed that change sometimes happens suddenly, and that is used today to explain fossils a lot. As I told you, when you look at fossils, there are gaps, and many scientists, like the famous Niles Eldridge or other famous evolutionary biologists like Stephen Jay Gould, in the 70s, they came up with the concept of punctuated equilibrium, which is basically that evolution happens gradually, not gradually, but in jumps, and you get periods of no change, followed by a jump, followed by another period of no change, followed by a jump. Now, this concept must have been around for a while, because you see it in Saadi, you see it also in other authors, but Saadi also advocates that. So he believes in both types of evolution, gradualism and also punctuated equilibrium. Now, when it comes to the nation, this is very interesting for me, because if we compare nations to species, in biology, species would be defined based on geography and reproduction. So a species is a group of individuals of sharing certain characteristics, living in one place at one time, interacting together, making kids that can themselves make kids. This is how Darwin looked at species, and this is how most of modern day biologists, they look at species. When Saadi defined the nation, he referred to many factors, including geography and ethnicity, in addition to other factors like culture and history and so on. And to me, as a biologist, the striking difference is when it comes to blood and soil. So blood kind of corresponds to the ability to intermarry and leave viable offsprings who could produce offsprings, and that corresponds to his selective melting pot, where what you get today as a civilization is actually the mixing of selected groups of successful social groups that, or sulalet or lineages that actually intermingle together. And then there is soil, which refers to the geography, a specific historic geographic context. And this is very similar to our definition of species in the biological sense. There are many, many definitions of species, but this is just one of them. Now, as for change, Saadi believed in change, and he believed that this change should happen through continuous education, and that education in society is crucial. It's important who does the education. It should be a vertical hierarchy where the more educated would help the less educated. And so basically it's a permanent process that happens again and again and again. And he was against superficially educated masses. So he was basically pro one group of the more educated helping the less educated in society. And then finally, we're going to talk about Saadi and racialism. And I have to split between racialism and racism. So we're not talking about whether we like or hate other races, but we're talking about races as such. And so Saadi rejects purity of races, or purity of blood, as he calls it. And this is something that was common among fascist thinkers, also Nazi thinkers in Europe at the time. He emphasized that the Syrians, or the Syrian people, are a result of some kind of mixture of very successful lineages, and he lists many of these. And he believes that progress partially should be attributed to the openness of society. And in one of the examples he gives, he takes Athens versus Sparta. Sparta was more a pure lineage, which was not open to the outside. Athens was more of an open society, and so he believes that Athens was more successful than Sparta because basically it was more open, and so it was a melting pot where different lineages could mix. Okay? Now, the next stop will be with Husserl, and after that we will open the discussion towards the end. So Husserl is the founder or father of Arab nationalism versus Syrian nationalism. And again, we're going to look at the same four aspects. We're going to start with his view on evolution, change, the society, and racialism. And I will start with evolution. Anybody familiar with Husserl here? Okay, well, good. So you can correct me if I am not accurate. So when it comes to Husserl, he accepted the theory of evolution by natural selection, but he strongly rejected applying it to society. Now, with Husserl, we're going to see that he actually accepted it as a scientific fact, but he moved away from applying it in social contexts, whether at the level of definition of society or at the level of evolution of society. So he believed that since evolution is a slow process, and since evolution is based on the fact that genes determine what we have, so basically things are genetically determined, he believed that if we accept this at the social level, it means we are saying that if some societies are not changing as quick as they should, then it is because of an inherent property in them that is preventing them from changing as fast as they should. And so this is going to make us think that they are destined not to change fast and not thinking of improving their situation. So this would be a drawback. So applying it in a social context would be kind of a drawback, because it would be like assuming these societies will stagnate because of an inherent genetic property, and thus they cannot proceed. Now, in modern day sociology, they have coined the term meme. And meme corresponds to gene, except it's in a social context. And this is quite recent. So more recently, Dawkins talks about it, and then some of the other modern evolutionary biologists who actually went into the social realm, they talk about the social evolution using the concept of memes as counterparts of genes at the level of society. So in a way, Husserl accepted evolution as a fact, but he didn't want to apply it to society. Now, unlike Saadi, who defined the society based on blood and soil, so geography and mixing, he defined it based on language, which he called the soul, and history, which he called the memory of society. And so his definition is quite different from the biological definition. Here he diverges a lot from biological evolution. He believed that moral factors were way more important than physical factors and also material factors. And he rejected the idea that nations are comparable to organisms. This is something that we saw very prominently in the first generation of students of the founding fathers, like Schmeil and also like Farah Hantun. So he refuted this. He believed that it is the ties among the nation's constituencies, which are mostly moral, that are going to define the nation, and not some physical attribute that links members of the population. Now, as far as change goes, he actually believed that nations rise and fall based on their ability to catch up with progress. So progress takes place. Nations have to adopt and follow this progress. And if they can't cope with this progress, they can't change. And thus, he does not believe that soil or blood or both are involved in determining whether a society or a nation is going to fall or rise. It's going to succeed or not succeed. And here he disagrees with Saadi, and he disagrees with biologists who actually believe that the genetic composition actually affects organisms. Now, doesn't mean that if it works in biology, it works in society. We have to be very careful when we do that. And he attributed difficulties in achieving Arab unities to the governments, because he believed that those governments, particularly the ones that came post-partitioning the nation, were the ones responsible for what happened to the Arab nation, so being behind and being unable to follow progress. And then finally, and I will conclude with this before I conclude the talk, Husserl rejected all kinds of racialism. He didn't accept, well, yes, also racialism, both. He rejected both. So he wasn't racist, he wasn't racialist. He didn't believe in eugenics, which is improving lineages. And he didn't also believe in any similar theories. And in here, when he comes into examples, he becomes extremely controversial because he takes classic examples, or not necessarily classic, but controversial examples from other authors of his time, and he kind of debates them. And it gets really tricky. So it gets at the border of fights. So I'm going to stop here for now and thank you and ask the audience for questions.